Good afternoon, everyone, and happy Friday. We finally made it. So, once again, we are going to have a recorded class today as I am on site conducting tag testing. So, we are going to start with our bell ringer today. This is the way that you will receive your credit for classes by answering this question in the team chat. If I do not receive your answer, you will be marked absent for today. So, take a few moments to read over the bell ringer question and pause the video to put your answer in the chat. But today it asks, in which layer would the oldest fossil be found? Is it layer A, layer B, layer C, layer D, or layer E? Go ahead and take a few moments, pause the video here, and put your answers in the chat. All right, and hopefully you chose layer E. But if you did not, that is okay. I just need to see your answer in the chat for your credit for class. Remember that our oldest fossils are going to be found in our deepest layers because as time goes on, those layers build up. And with taking a look at our agenda today, we are going to briefly go through our procedures. We're going to continue our lesson with looking at DNA evidence in our mini lesson, and then you'll spend the remainder time working on your assignment in Canvas. And with our announcements, remember that on Monday, we do have our teacher PD day, so there'll be no school on Monday. So you all get your 3-day weekend. And with our assignments and due dates, we have our 07.04A fossil and DNA evidence quiz due on today. So we want to be sure we get that quiz completed. As we continue in our evolution unit, our standard is S7L5C, where we analyze and interpret data for patterns in the fossil record that document the existence, diversity, and extinction of organisms and their relationships to modern organisms. Our learning target states I can identify evidence of evolution. So let's continue with wrapping up and looking at evolution. So as we continue to look at evidence of evolution, we want to take a look at the forearms of these various animals. You would think that animals such as these will all have different bones in their arms and very different anatomies in their skeletons. After all, their functions are so very different. Despite having different functions of their forearms, these animals have the exact same bones. Homologous structures are similar in their anatomy amongst different species. Homologous structures hint that the organisms share a common ancestor. So we're looking at the forearms of a human, dog, bird, and whale. They all contain a humerus, radius, ulna, carpals, and the metacarpals, as well as phalanges. Another example of homologous structures are the backbones or vertebrae of various animals. Giraffes, dogs, humans, and pretty much all other mammals have 7 neck vertebrae despite their vast differences in size. Analogous structures are those that are different than homologous structures. Analogous structures are the structures that have a very similar function but are very different in their anatomy. These show that the organisms do not have a close common ancestor as they have developed very differently. Wings are covered in thin overlapping scales with no internal bones in their wings, whereas the wings of this bat all have the same bones as other mammals' forearms, being a humerus, ulna, radius, carpals, and phalanges. Another form of evidence of evolution are vestigial structures. These are structures that remain on an organism even though they have lost all or most of their original ancestral function. You might not guess it from looking at the snake, but it has tiny leg bones. Snakes have evolved over time to looser legs, but the tiny bones still remain as a part of their anatomy. Scientists also find evidence of evolution when examining the embryos of various animals in a study called embryology. And an embryo is an unborn or developing young. This diagram shows 8 different species embryos. Take a look and see if you can guess which animal is which. Your choices are turtle, human, chicken, salamander, hog, fish, rabbit, and cow. So we start off with stage 1, and they all pretty much look very similar. Then we go into stage 2. We start to see some differences. And then we have stage 3. And stage 3 is where you can see some of the vast differences in the different organisms. So our first was a fish. Then we have our salamander, our turtle, chicken, hog, cow, rabbit, and human. Go ahead and put in the chat how many of those you got right. And for your answer for this, you'll receive some PBIS points if I see it in the chat. DNA has revealed and continues to reveal a great deal about evolution. By comparing the DNA of different organisms, scientists can chemically map out how organisms have changed and how closely related they truly are. Scientists have located the points of mutations and see the similarities and differences in their genes. This shows just a small section of a DNA gene across 3 different species. Which 2 of the species would you guess are more closely related based on this small section of DNA? DNA also has an expiration date. DNA breaks down over time, and the oldest DNA found so far was about 1 to 1.2 million years old. They came from a mammoth's teeth. So as we wrap up today, our target has been to identify evidence of evolution. You all are going to continue working on your assignments, but focusing on your 07.04a fossil and DNA evidence quiz. Remember that is due on today. And as always, if you have any questions, just send me a message in Teams and I can definitely respond back to those. I hope that you all enjoy the rest of your day and have a great and safe extended weekend. And I'll see you all back soon.